Yes. Oh, she's not here today, actually. Yeah. Yeah. Mhm. Okay, yes, sounds good. Okay. Okay, sorry about that. So let me go ahead and dive right in to today's lesson. Okay, so today we're going to look at transformations of quadratic functions. So basically what this means is we have the standard form for our quadratic functions, and we're going to look at what we do to transform that, to move it around, to make different transformations. And so the different types of transformation, well, transformation of an equation is an operation on an equation that may change its location in a plane or its shape. So here we see different types of transformations occurring to that original blue line. So our original blue line would be our standard form, and then all the other lines indicate something transforming, the transformation occurring. We can have translation, which refers to as a slide. We can have a reflection, which refers to as a flip, or we can have a deletion, which refers to as a stretch or shrink. And so we'll see how we can perform these different transformations about the standard form. So our standard form is going to be y equals x squared. And so if we were to graph y equals x squared, we'd see that graph in standard form. Let me see if I can actually show you what y equals x squared is in standard form. Let's see if it'll let me. Okay, so this is our standard form. So what we're going to do is we're going to take this graph and we're going to transform it, and we're going to see how we do these different types of transformations. So let me go back. Okay. So how do we do a vertical translation? Vertical translations go up or down. So we're trying to see, how do we go upward or downward, up or down? Well, the way we do that is we add a value. We add a value of k. So we add a k, and whenever we add a k, what we do is we can shift that up or down. This is because k is added to the y values of y equals x squared. The y values increase and decrease, causing vertical shifts. So if we have a k which is greater than 0, the graph will shift k units upwards. So say I have 3. 3 is greater than 0. So if my k was 3, then I would move 3 units upward. Okay. However, if my k is less than 0, then I will move downward. So say that my k, I'm not actually adding 2, maybe I'm subtracting 2, so I have -2. Well, -2 is less than 0, and so that means I have to move downward, so I'd move 2 units downward. Okay, and here we can see some examples. Here we added 2, our k is 2, which means it's greater than 0, so we go 2 units up, 1, 2. So that orange line would represent that. Here we have a -1, which is less than 0, so we're going to move 1 unit downward. So you can see there that we moved 1 unit downward. Okay? So that is when we add a k or subtract a k. Adding a k moves upward, subtracting a k moves downward. Okay? Does anyone have any questions about this? So this is vertical translation, up or down. Okay? Now we're going to look at horizontal translation. So we know how to move up and down, but how do we move right and left, or left and right? Okay, so we're going to look at that. Well, basically we want to take our standard, which is x squared, and our h, whatever we add or subtract to our x, is going to allow us to move right or left. So this is because h is subtracted from x. The same graph appears when x is h units greater. So basically, we're just shifting right and left. So we're adding something which is h. If our h is greater than 0, the graph will be shifted that many units to the right. And if that h is less than 0, then we will move that graph h units to the left. So in this example, we added 2. 2 is greater than 0. And so that means we're going to move 2 units to the right. And so we can see that actually happening. Here's our standard. We're moving 2 units to the right. 1, 2. So that's where our points move. So we moved it 2 units to the right. Here is our other one. This is -3. So -3 is less than 0. And so because of that, we're going to move 3 units to the left. Because if it's less than 0, we move to the left. Okay. So 1, 2, 3. 3 units to the left. Okay, so if h is greater than 0, we move to the right. If h is less than 0, we move to the left. Any questions here? Questions, concerns? No? Okay. Now we're going to look closer at what equation are we even working with. Well, what we're working with here is what we know as the vertex form. The vertex form of a quadratic equation is in the form y equals a x minus h squared plus k. So that is our equation in vertex form. Basically, we took our quadratic equation and put it into vertex form that we see here. The a, h, and k are real numbers. A is not 0. And h and k will represent the vertex of our parabola. And so we'll look at this a little bit further. Okay. So here we have an equation in vertex form. And so vertex form kind of just transforms our quadratic form. And so we can actually go from vertex form to quadratic form. And the way that we do that is we basically just apply all the different methods. And so the first thing we can do with vertex form is we can identify what we know as the vertex. And our vertex is our h and our k. Like we saw in our vertex form, this is our h, 2 is our h, and k is our 1. So we could say here that our vertex is 2 and 1. What we can also do with this is we can go ahead and make it into quadratic form, our standard quadratic form. And the way that we would do that is this is basically saying x minus 2, because x minus 2 squared plus 1. We can apply our FOIL method. Plus 1, put our like terms together. Plus 5. And so now we have our equation in our standard quadratic form. Our standard quadratic form, just a reminder, is ax squared plus bx plus c. Okay. Any questions on how I went from vertex form to quadratic form or standard quadratic form? Questions? Any questions about how I found my vertex? No? Okay. Now we're going to look at what happens if we change something about A. So we're going to look at how A affects the orientation of the parabola. So what happens if we change the value of A from positive to negative? Well, if we go from positive to negative, what happens is our orientation changes. Basically, we have to flip the graph upside down. The vertex will stay the same, but the parabola will be reflected over the line y equals x. So basically, here I have 2 equations, and it's saying if I change A from positive to a negative, what's going to happen is that my vertex will stay the same. So this is my vertex, my parabola. It'll stay the same, but what's going to happen is my graph is going to be flipped. So whenever I have a negative a, my graph is flipped. Okay, same thing for over here. There actually is an a here. It's just imaginary. The a would be right here. And so if I were to create an equation y equals negative x minus 3 squared plus 1, and then remember there's an imaginary a right here. If it says negative, then I'm going to, again, keep my vertex the same. The vertex will stay the same, but my graph will be flipped. So it'll be flipped about that vertex right there. Okay. And then just a reminder that these points are your vertex. The very bottom of your parabola are your vertex. And again, we can find vertex using h and k. So like this is an example. What is the vertex of this blue line? Well, this is our h. This is our k. And so our vertex is 3 and 1. We can check that. Is this at 3 and 1? Yes, it is, in fact. So that is our vertex. Okay. So whenever we have a negative a, our graph is flipped. Okay. Any questions about this? Questions, concerns? No? Okay. What if we have an actual number for a? What if, we'll see right here, the effects of a on y equals ax squared. So what if a actually has a value? It's not imaginary like in the other one we saw. Well, if a actually has a value, what happens is that will stretch or shrink our original graph. And so if a is greater than 1, the parabola will stretch vertically. So if a is greater than 1, our parabola will stretch vertically. Let's see an example where a is greater than 1. This purple one shows us that a is greater than 1. And so by it stretching vertically, okay, this is going to be a little difficult, but this, actually I can show you. So, okay. So we're working with these two. Now go ahead and graph these so we can see them. So now I'm going to apply where a is greater than 1. Just give me 1 second to identify it. Okay. And what you'll see there is the red graph was our original graph. The blue graph is our change graph. And what you see is it's stretched vertically. So it kind of is pulled up a little. And so stretching vertically is going upwards. So if you think about it like a string where you pull it up, it gets a little skinnier, but it's also longer. And so that a is greater than 1 tells us that we have our parabola stretched vertically. If we have an a which is less than negative 1, our parabola gets flipped and stretched vertically. So less than negative 1, I'm going to do, let's see, negative 1 over 6. No. Yes, okay. So, is that the one I want to work with? Give me 1 second. Trying to see which one gives us the best representation of what I'm trying to show you. Let me do negative 4. Okay, so if a is less than negative 1, so negative 4 is less than negative 1, the parabola will get flipped because it's a negative, it gets flipped over, and then it is stretched vertically. So you see how it's a bit longer, it's kind of pulled more upward. And so that is when a is less than negative 1. But then what if we have a being greater than negative 1, but also less than negative 1? Then say that is where we have our example I'll do negative 1 over 6 x squared, then what happens if our value of a is that small? Then it is still flipped, but what you'll see is it's actually widened. It's not vertically stretched, it's actually vertically widened. Okay? So that is how a will affect, oops, I did not mean to do that, how a will affect the stretching or shrinking of our graph. And the easiest way to identify what is happening to these graphs, any question, is to actually go ahead and graph it on your own and see what the different changes are. But again, this is for A. The different values of A do different things to the original. Okay. The last thing we're going to do is we are going to see what we can identify here. So it says identify the constants in this vertex form. So by identifying the constants, what we're going to do is we're going to identify our vertex, and we're going to be able to identify our value A. So vertex, value A. So our vertex again is our H and our K. Here our H is 7 and our K is 9. So 7 and 9 would be our vertex, and our A is 5. This second. Here we see our A is a negative, so we could say it's negative 1 because that doesn't actually have a value, so I'll say negative 1. And then our vertex is our H and our K. So 3 and negative 4. The reason it's 3 is because it doesn't alter the sign of the original, so we keep that as the positive version. But because this does change the sign, it goes from positive to negative, then we know that we actually applied the negative 4 there to change that sign. Okay. Any questions on how to identify the vertex or the A in vertex form? Any questions? Okay. Okay. Give me 1 second, guys. Okay, sorry about that. Okay, so now we're going to see how to complete the square to change a quadratic function to a vertex function. So this one's a little bit different. The first one we went from vertex to quadratic. So what we're going to do here is we're going to go from quadratic to vertex. But the way that we do that is we need to complete the square. That is because the standard form has xh squared plus k. And so we need to identify what this component of that vertex form is. So we need to complete the square. Basically, we're just going to do the same thing that we've done before for completing the square. We're going to go ahead and put it in x squared bx is equal to c. So my c in this instance would be negative 5. I can do it the other way so we're not too confused. So basically, I'm just moving the c over to the other side of the equal sign. So this is what I end with. That allows me to complete the square. So negative 4 squared minus 2, negative 2 squared, 4. So that means I have to add 4 to both sides. And I'll do here, add 4. And I have to add it to both sides to make it even. You can't just add to one side. You have to do it to both sides. And that allows me to complete the square. The square root of 4 is 2. And so my completed square would be 2. and then equals -1. And so now I can move that c back over. So that would be x -2 squared plus 1 equals y. And what you'll notice is that is actually my quadratic form. My a is just nothing in this instance. I have x minus h. My h is 2 in this instance. And then my k in this instance will be 1. And so that allows me to transform my quadratic to vertex form. So the first thing I'm going to do is I'm going to complete that square, which we've gone over already, how to complete the square. But after you complete the square, you're going to factor that perfect square trinomial. And then that will allow you to get your answer in vertex form. Okay, so we completed the square here by adding 4 to both sides. Then you actually go ahead and factor that out, which is x minus 2, which we did over here. And then you move that c back over so that you can have it in your vertex form. Okay, any questions about what I did here? Questions? No? Okay. So now what happens if a isn't 1, it's actually greater than 1? Well, kind of the same thing, except in this instance, we're going to factor out. Okay, first thing we're going to do is we're going to put it where my c is on the other side, because that's the way that we complete the square. And in this instance, we are going to need to complete the square. Okay, but what I notice is that my a is greater than 1. So what I need to do is see if I can factor something out of that to make it where a is 1. And what I can actually factor out is 4. And this is actually -5. I don't want to mess that up. -5. Okay. And so I factored out that 4. That gives me now an imaginary 1 for my a. And now with that, that's where I can complete the square. So I need to complete the square to see what the perfect square trinomial is. So -2 divided by 2 squared, -1 squared, 1. So I'm adding 1 to both sides. So add 1. And what I'm actually going to do is, because if you really think about it in retrospect, I'm not just adding 1. When I actually go back and distribute this out, I'm actually adding what to 4, because 4 times 1 is 4. So in reality, I'm adding plus 4 because I took out that 4. So whenever I take it to the other side, I want to make sure I'm adding that same amount back in. So I can either do it where I add 4 times 1, or I can actually add that 4 in. But in this instance, you will have to add 4 to the other side, because in reality, you are adding 4 to this side to complete the square. Okay, does that make sense? Yeah, okay. Just want to make sure you're not getting confused. Okay. So I'm just going to rewrite this. So that means I added the same thing to both sides. Now that I added the same things to both sides, I can actually go ahead and factor right here. And when I factor this equation in the center, that is x minus 1 squared. How did I get that? Square root of 1 is 1. And so that's what's going to be placed in here. And then equals, what is this equal to? -5 plus 4. -5 plus 4 is -1. And so I can move that back over. So 4x minus 4 squared plus 1 equals y. And so that is my vertex form. Except in this instance, my a is 4, my h is 1, and my k is 1. Give me 1 second. Oh, never mind. Okay. So that's if you have a is not equal to 1. If you have, in this instance, you had a 4. And so because of that, you want to make sure that you create a factor which allows you to only deal with the 1, because that's easier to complete the square. Okay, any questions? Okay. So basically we went over today, the vertex form of a quadratic equation is y equals a times x minus h squared plus k. The vertex of the graph will be whatever h and k is. And then the constant a indicates whether the parabola opens up or downward, and its magnitude affects the width of the parabola. So again, if we have a negative a, then we flip that graph upside down. And then depending on the type of a we have, you can tell whether it shrinks or it doesn't shrink. And on top of that, give me 1 second. Almost done. Okay. And on top of that, the other things that we went over is what happens when your k is greater than 0. If your k is greater than 0, it's upward. If your k is less than 0, you have a translation downward. So translation upward, translation downward. If your h is greater than 0, then you move to the right. If your h is less than 0, you move to the left. Here we have if a is greater than 1, if a is less than 1. And then here you have a little more information about how we went from quadratic to standard form, if you want to reference that. Okay, but this is posted for you already. But does anyone have any questions about anything we've gone over today? Okay. If there's no other questions, have a great weekend, and I will see you guys on Monday. Bye, guys.